Welcome to Notebook 22, Runnable Functions. In this notebook, you're going to learn how to convert custom functions into runnables that you can include in LangChain chains. By the time you complete this notebook, you'll understand how to create custom runnable functions and include them in your LangChain chains. You will use custom runnable functions to do some data pre-processing before sending it to an LLM. You'll use custom runnable functions to batch translate raw text into prompt templates. And finally, you'll create a LangChain sentiment analysis chain that utilizes multiple custom runnable functions. We'll begin per usual as making some imports. We have one new import in this notebook, which is runnable lambda. We'll be looking at this in more detail below. And then per usual, we will create the LLM instance that we'll use in this notebook. Okay, so using runnable lambda to create custom runnable functions. We've already seen that LangChain provides composable runnables in the forms of LLM instances, prompt templates, and output parsers. These are the three runnables you pipe together into chains in the previous notebook. Another very powerful tool that LangChain provides is the ability to convert arbitrary functions into LangChain runnables with the runnable lambda helper. So we're going to import that again here just so you can see it. It resides on the LangChain core.runnables and is called runnable lambda. Okay, so again, the claim is that we can convert arbitrary functionality into runnables. So let's look at a very simple example to kind of drill this point in. So here's a Python function, just a regular old Python function called double. It expects a single number and returns 2 times that number. So obviously, it should come as no surprise, right? But we're going to make this very, very clear that a raw Python function does not contain the methods that a LangChain runnable contains, namely batch and invoke, right? So, I mean, again, we're going to try to take this Python function and invoke it with 2, and it should come as no surprise that we actually get an attribute error here. And you can see, double is a Python function and does not have an invoke method. The point being that, what if we had some arbitrary functionality like this that we wanted to use on our chain? Well, it turns out that Python functions do not implement the runnable interface and therefore cannot be used as a runnable in LangChain. However, we can easily convert it into a LangChain runnable by passing the function definition into runnable lambda, which is what we'll do here. So here we're using runnable lambda. We're passing it our double function, and the returned runnable we're calling runnable double. And as we would expect now with a LangChain runnable, it now has an invoke method. We'll invoke it with 6. You can see 6 times 2 is 12. That makes sense. Just to test it out, we would assume that because it's a runnable, we can also batch invoke it with a list of values. So here we pass in a list of numbers and we get back a list of doubled numbers. So far so good. Another characteristic of runnables that you know about is that they can be piped into chains. So let's try that with our runnable double. Here we're going to create a chain called multiply by 8, which is going to pipe the output of runnable double into runnable double, and then again into runnable double. So this is 2 times 2 times 2, which is 8. So that's why it's called multiply by 8. And you can see if we invoke this with the number 11, we get back the value 88. So that works just fine. So we've kind of sanity checked our claims that we can take arbitrary functionality and using runnable lambda get a runnable back that behaves just like all the LangChain runnables we've used up until this point in time in the course. It's really worth pointing out at this point in time that this your ability to use this is limited only by your creativity, right? So you might use any number of custom runnables for all kinds of things in your chains. But that said, we can't cover absolutely everything. We are going to look at 2 use cases for custom runnables that we find show up quite a lot. And then furthermore, I'm going to give you a chance to kind of practice creating and using custom runnables. So the first one has to do with data management. Whether it's for formatting, doing some sort of correction or validation, there's a good chance that you might want to perform some kind of work on data that's going to pass through your chains. either before or after interacting with your large language model. Just as an example, let's suppose, right, this is kind of a made up situation that's meant to highlight the use of runnables. It's not necessarily what you would do in an application, although you might. But let's just suppose you're building a sentiment analysis application where you're getting user reviews and you found that the sentiment analysis is working a lot better for you if the incoming text has been normalized. So specifically, you've noticed that sometimes there's inconsistencies in like capitalization or white space or the use of contractions. And again, kind of in this fabricated situation, you've just found that if you can pre-process the data before you send it to your LLM for sentiment analysis, the results you're seeing are a lot better. So we would like to normalize this text before sending it to the LLM. And furthermore, we would kind of like to do that as part of our chain, right? We just want this to be a constituent part of the sentiment analysis chain that we're aiming to create. So here we have a function that we've created called normalize text. You don't need to worry about it too much, but basically it's taking an input of text and lowercasing it using the contractions library, which we've pip installed already to fix any contractions, right? Expand them into non-contractions. And then furthermore, we're just using a little regular expression to substitute out any extra white space that might be hanging out in the incoming text. Again, the functionality here isn't the important part. The important part is we have a situation where we want to do something with our data before sending it to the LLM. And as an example of that, we're using this specific normalize text function that we've created here. So with that normalized text function, it's now time for you to do a quick exercise. So using what you've learned already about creating runnable functions, create one out of normalized text. And if you do this successfully, then you should be able to use that runnable and batch in these following reviews and get back a list of each of these values having passed through the normalized text function that's defined above. So give that a chance, pause the video, and then when you're done, come back and we'll look at the solution together. Okay, hopefully you found that pretty straightforward. Here's our solution. All we're doing is taking our normalized text function and we are passing it into runnable lambda, which then returns a runnable. We could have stored this in a variable if we wanted. Probably would have made more sense in the larger context of things. But assuming that we have that custom runnable, which we do now, we can use the batch method as we can with any LangChain runnable. And we pass in this list of reviews, which I need to define. And after calling batch, you can see now that each of these input strings have been successfully batched. We've had our contractions fixed, right? We've had this kind of nasty trailing white space removed, and we've lowercased everything as we would hope. And again, it's not that these particular kinds of normalization are what you should do in every application, but you can see we've performed some custom functionality on incoming text in a way that now, as we'll look at, because we've done this with a runnable, we're going to be able to include it in a larger LangChain runnable chain. Yeah. Okay, so data or text processing, either pre-processing or post-processing, is a super common place where you're going to find yourself using runnable lambda. Another really, really common place you're going to find yourself using runnable lambda is for formatting text for a prompt template. So, in the previous exercise, right, we ended up with a list that basically looks like this. Now, let's assume that we would like to pipe these normalized reviews into a prompt template for sentiment analysis. For example, the following sentiment template, which expects a single version of text, right? So we know from previous notebooks that to invoke the above template, we need to pass in a dictionary that contains keys for its placeholders, namely a text key, because that's what the prompt template expects in the above template. So as an example of how we would do that, we would invoke it with a dictionary that has a text key, and we put in the actual review here. So However, all we have after running our reviews through our normalizing function is a raw string, right? We don't have these dictionaries that we need. So in order to prepare the item in normalized review for being piped into sentiment template, we need to convert each line of the text into a dictionary with the key text and the value of the actual line of text. So in order to do that, we can use runnable lambda. So for this function, which we're going to call prep for sentiment template, we're going to invoke runnable lambda, and we don't have to use a Python lambda here, right? We could use a longer form Python function, but in practice, a lot of times you have these little one-liners, so it makes sense to use a Python lambda. This particular Python lambda function expects a single value as input, which is text, and it returns a dictionary with a text key and whatever was passed in as text as the value associated with the text key. So with that now, because we passed this Python function into runnable lambda, we now have a LangChain runnable called prep for sentiment template. And as we might expect, we should be able to batch it with our list of normalized reviews. And we can see that we get a list back, and it's a list of dictionaries that has been correctly formatted now for being passed into a prompt template. Okay. Again, this is one of the very common sort of situations you're going to find yourself wanting to use runnable lambda. So with what you've seen so far, we have another exercise for you in this notebook. Specifically, we want you to create a sentiment analysis chain that you can pass in the original reviews list into as a batch. Okay, so let's go back and look at reviews since it's been a while since we looked at it. It's already defined for you. It's called reviews, and here it is. You can see it hasn't been pre-processed yet. It's certainly not ready to be passed into our prompt template, but it is defined, right? We also have our normalized text function already defined for you. We also have a sentiment template already defined for you. We also have a prep for sentiment template runnable already defined for you. So your goal is to create the chain that's going to chain all of this all together. And your chain should normalize the raw reviews, prepare the normalized reviews for use in the sentiment template, pipe the prepared normalized reviews through the sentiment template, pipe the prompt templates into LLM, which again is already defined, and then conclude by parsing the LLM outputs with an instance of string output parser, which we haven't used in this notebook yet, so you'll have to instantiate that yourself. So several steps, but hopefully it should be pretty straightforward for you. Please give that a chance, pause the video, and we'll come back and look at the solution together. Okay, hopefully you were able to create a chain that did all of the different things we wanted to. And hopefully as you're kind of learning how to compose chains like